Okay, everybody, let's have a look at the features of a graph. So the features of a graph just mean what does it look like? Can you describe it using your English words? So here's a very simple graph that we've maybe remembered from last year. We call this a parabola or maybe a quadratic graph. So the main part of the graph is affected by this x to the power of 2, x squared. It is a quadratic, and we call this shape a parabola. If you do science, you'll learn a lot about parabolas and how they are useful, maybe in physics. But for now, we're just concentrating on its shape. It's a curved graph because there's no straight lines in here, and we're interested in a few of its features. Oh, excuse me. Too much talking. Right, so the very first thing I can tell you is it looks like kind of like a giant letter U. And I'm using the letter U because we like to focus here on the turning point of our graph, the bottom of our graph. It gets flatter and flatter and flatter until it is dead flat. And then it starts to curve back up again. So it possibly looks more like a letter V, but we call it a letter U because of this turning point down here. Okay, so things we can do to our graph to change it quite simply. I'm going to leave this one on and I'm going to turn some of these other graphs on and off. First thing I can do is times everything by -1, and my graph turns upside down. So I've got exactly the same graph, except it goes the other way. So if I was to describe the blue graph, I'd say it's a parabola. It's upside down because of the -1, which is hiding there in the front. I can put it in there if you would like to see the -1. It's going to make no difference whatsoever to my graph. Same shape. It's a negative upside down parabola. It goes through the point 0 and 0. There it is, right at the top of this graph. And that's the only really other interesting point on my graph. Okay, let's have a look at this one. So I'm going to turn off the negative graph and I'm going to turn on y equals 2x squared. So everything is doubled. It happens twice as fast. So if I look at this point here, 1 and 1 on my, 1 and, let's zoom in again. There it is, 1 and 1 on my red graph. But everything's doubled, so on the green graph it's 1 and 2, if I can get that exact point. Oh, I went past it. There it is, 1 and 2. Okay, so everything's been doubled. I'm going to turn this one on at the same time as well. Here's a third of x squared. So what's happened is it's been made a little bit flatter, a bit squashed. If we zoom out, the green one, 2x squared, is very steep. X squared itself is still quite steep, but 1/3 is getting quite flat, especially here towards the bottom. All right, let's turn those off. Now what I'm going to do is add a number to the end, x squared plus 4. And what simply happens is the x squared graph gets moved up the x-axis to 4. So if I'm to describe this black graph, it is a parabola and it goes through the point 0, 4. There it is on my graph. Okay, I'm going to turn that one off and we'll do this one. Okay, it's giving me another red graph, sort of reddish. Okay, x squared minus 5. It is a parabola which goes through the point, its turning point, its bottom of the graph is at 0 and -5. Okay, so these graphs are kind of dull in a way. They don't have too many features because they're right on nice lines. Let's do this one. Okay, so here we have another parabola. It's exactly the same shape as an x squared graph, but it's been moved over to the bottom of the graph has been moved over to -4. This is because if I put -4 here, -4 plus 4 makes 0. It moves it sideways 4 places. My blue graph is a parabola, and the bottom of my graph is at x equals -4, y equals 0. All right, let's have a look at this graph. Again, an ordinary parabola. It's the same shape as my x squared graph, but the turning point, the bottom of the graph, has been moved to x equals 6. So my simple descriptions would be it's a parabola and the turning point is at x equals 6. All right, so let's try this one. So this particular graph has been set up in a way that I can change a few things. So I can change that power out in front of my graph. So I can make it a little bit shallower. I can make it steeper than my other graph just by changing the letter A, the power that's in front. If I make it 0, then we just get a straight line. Okay, so let's keep it at 1. Okay, I'm going to try and move my graph sideways a little bit. There we go. I'm going to move it across to -4, and I'm going to try and move it up a little bit. Well, it's not quite at -4. Let's change this to exactly 4. So I'm talking about this new red parabola. It's a parabola. It's a standard shape, but the turning point is at x equals -4 and y equals 2. Okay, so I'm going to get rid of that really first one at the moment and try and look at a parabola that we might have. So I'm reasonably certain that the turning point might be there somewhere. I'm going to flatten it out a little bit, going down to 0.1. And so if I had a few dots along here, say that one, can I make it do that one? No, it doesn't want to, does it? Okay, so it's given me this point, which is my turning point, the bottom of my graph, -1.2, because this is positive 1.2. And here's my intercept at 2.144. Okay. Right, let's try and move it across a little bit more maybe. Okay. So I'll move it across there. Okay, so here's my parabola. The turning point of my parabola is here at -1.9. The scale factor of my parabola is 0.1, so it's been flattened out quite a bit from a normal parabola. And the intercept point here is at 2.361. Okay, the last thing I'm going to do is just turn my parabola upside down. I might take it up, across, and up a bit. So now my parabola is here. Click on it, and I'm going to get my turning point at 4.3 and my y-intercept at 4.453. Those are quite nasty numbers. Let's see if I can make some nice numbers. Go to 5 and let's see. Oh, that's a little bit nicer, I guess. Turning point here at 5 and 10 and my y-intercept at 2.5. So my last description, this is a parabola. It's an inverted upside down parabola. And the turning point here is at 510. The y-intercept is at 2.5. My two x-intercepts are at -0.774 and 10.774. Okay, so those are some of the features of my graph. To get achieved, you must be able to describe a couple of features of your graph. To get merit, you must be able to describe the features of each graph that you use. That's all for now. We'll see you next time. And this